Hello, 7A scientists. I hope this finds you doing well today. Today, we're going to focus on sex traits and disorders. So, we're going to merely be focusing on chromosome number 23. Right? There are sometimes disorders carried on the X chromosome. And we're going to talk about that and how those traits show through. All right. So, I'm going to just give you a little background information. So usually you have hitchhiker thumb, no hitchhiker thumb, right? And no hitchhiker thumb, the other allele, right? Widow's peak, right? Widow's peak, no widow's peak. So there's two alleles um, as a result of one gene. But sometimes there are multiple genes that go into play for your characteristics. Like your hair color is not just brown, black, blonde. There's shades. Some kids have really light brown hair. Some kids have very dark brown hair. Blonde. Some kids have dirty blonde. Some kids have red, right? So your gonna traits is controlled by more than just one gene for two alleles. Like there's several. Okay, so hair color, eye color. If you keep going through the slides, and I'm looking down because I have another computer slide. Sorry, I'm looking away. Your blood type 2 is another one, right? You've got type A, you've got type B, you've got type AB, O positive, O negative. Whole slew, more than one gene on more than one chromosome that actually take part in all of this. So you've got several different forms, all right? So just be aware of that, right? So we did that one. We are going to look at so Punnett squares, okay? And we talked about the probability of you being a boy or a girl is a 50-50 shot each time there's a kid, right? You're either going to have XX or you're going to have XY. XX is a girl, XY is a boy, right? And this is chromosome number 23, right? So that very last pair of chromosomes, XX, you're a girl, XY, you're a boy, okay? So sometimes there are some disorders that are carried on the X chromosome. Okay. Generally, you're not going to see any chromosomes on the Y chromosome. Okay. The Y chromosome is smaller than the X. If you remember when you looked at that printout of a karyotype, like all the little chromosomes lined up in a row. The last one, the XY, if you were a boy, one was like this for the X, and then the Y was really kind of small. So there's not a lot carried on the Y chromosome as far as genes go, too, or traits. And if you think about it, too, it would only be something on a boy, right? So there's not a lot of traits on the Y chromosome. But you never know because think about when we were in class. Um, Sometimes you got some boys that like to burp really loudly, burp, burp really loudly. I wonder chromosome that scientists just never really talk about. Something to ponder. And boys, you know who you are. It's the first, the loudest out of everybody. Anyway, just joking. Haha. So what you're going to see is the traits or the genes for a disorder are carried on the X chromosome. Okay. Lots of times they are recessive disorders, right? And think about recessive is the small letters, right? So I'm using R for an example. So you would need two letters to show a recessive trait, right? Or something, whatever we're looking for. Let's take color blindness, right? So you would need two little letters, okay? But if you're a boy, you only have one X, right? You have an X and a Y. So it's whatever letter, make it neater, that's going to show on this X chromosome, if you're a boy, is what kind of trait is going to show through because it's not in competition with another letter like in a girl, right? We're also going to see that girls, when it's a recessive disorder, girls don't usually have that disorder. They can, but it's rare. But they can, and they are usually what's called a carrier. So when you see a heterozygous, right? A big and a little. Say this was for color blindness, okay? The girl is not going to be colorblind in this case because she has a big letter. But she's a carrier, meaning her boys, if she has children, any boys that she has, if they got this letter, instead about when we're talking about sex-linked disorders, mom passes that trait onto her children for a sex-linked disorder, and a boy only needs one letter, only has one letter for that. So the boy is either going to have the disorder or not. The girl usually doesn't, but can be a carrier. Okay, I'm going to show you. Okay. We also use subscripts. Okay, so if you're looking on the slide, as I'm going through this, for color blindness. Color blindness is a recessive disorder. Okay, so it's a little letter. Now we write. Okay, I'm going to give you all my little combinations. Okay, here's all my little combinations, okay? X big C is a normal seeing girl. And X, but she sees normal, right? She sees normal, okay? X big CY is a colorblind boy. Okay? Only way you can get a colorblind girl would be an X little c, X little c. X little c, X little c would be a colorblind girl. Only way you can get a colorblind girl. Okay? You gonna have that? Maybe. You might be. You might. It's possible. If it was a colorblind dad and a carrier mom, you can have that. Okay? So we'll write that in there. Colorblind girl. Okay? So we're going to talk about these, and we're going to try some. We make these little subscripts when we're talking about Punnett squares on sex-linked traits. It's really the only difference. Okay, you got to remember a little subscript, okay, or superscript up on top. Okay. Okay. So let's look at this. One of the crosses you have to make. We'll read our little scenario. This Punnett square just to show the probability of a man and a woman having colorblind babies. So we're going to cross a normal dad, and I'm trying to make my C's really big. A normal dad and a heterozygous mom. So she's going to be X big, X little, okay? So this is a normal seeing dad, okay? That's a big C, and a heterozygous mom. Mom is a carrier. Mom sees normal, okay? So just like we've been doing before, you're going to bring down those letters, okay? So first, let's bring down dad and bring down dad, right? And bring down dad and bring down dad, right? I brought down dad. Bring over mom. Big C. Big C. Little C. Little C. Okay? So when we're looking at this, XX is a girl. Big, she's normal, okay? X big CY, that's a normal boy, right? Because it's a big letter. X big C, X little c is a girl. She sees normal, but she's a carrier, okay? And X little cy is a boy, and it's a colorblind boy. Because it has one letter. So for a boy, whatever letter is whatever trait you're going to see when we're talking about boys, okay? So you would have, the way you would write this out is you would have One normal girl, one normal boy, one normal seeing girl, but she's a carrier, and one colorblind boy. Okay, so if we look at girls, there's a 50% chance, 1 out of 2, of a girl being normal sighted, and there's a 50% chance of a girl being normal sighted, but she's a carrier. Meaning she sees normal, but she's a carrier, so she can pass that on to her baby. For the boys, there is a 50% chance of a normal seeing boy and a 50% chance of a colorblind boy. And the reason why it's 50 instead of that 25, 25, 25, 25 is because if we're looking at boys versus girls, well, you've got 2 boxes. You've got 1 out of 2. Right? So your percentages change when we're talking about that. Okay? Okay? Make sense? All right. Okay. There is an Amoeba Sister video you're going to watch. It goes through sex-linked traits. And then there's, you're going to try a question on hemophilia. You're going to put the crosses in the boxes. And then there is Drosophila, which is a fly, which is what's on the front screen. We are looking at white eyes as a recessive link trait. Okay, so white eyes versus the normal red eye, and you're going to tell me what is the probability of the white eyes and all of that. Okay, so you've got 2 questions today. Hopefully this helps. It's just a special kind of cross. It's really the same. The only thing we add these little